12 years of hard work can all boil down to just 47 seconds in the pool. Heroes will be made and dreams broken, but there can only be one winner.
Every successful business starts with a great idea. Today, moving from concept to reality is easier than ever before. Join us as we travel around the world and meet developers, architects, and innovators to learn how they're building on the AWS cloud. Welcome to This Is My Architecture. I am here in Australia at the Gold Coast Aquatic Centre. It's 6 in the morning, and the Australian national swim team, known as the Dolphins, are here training.
It's your time to shine.
With their passion and dedication to the sport, it's no wonder they rank among the very best in the world. But for the swimming coaches and analysts, there's one aspect of swimming competition that takes more planning than the rest: selecting their relay teams. And Swimming Australia have an impressive new app for this. Hi, Jess. Would you mind telling me, why is it so hard to pick the relay teams? Wouldn't you just pick the 4 fastest swimmers?
You definitely go for the fastest swimmers, but there's all different orders that you can swim them in, obviously. So we have to consider a lot of different variables in a relay to make sure that, yes, the 4 fastest swimmers are in the race, but also that they're swimming in the best order to maximise their skills.
What prompted you to consider adding more technology in order to help improve the performance of the team?
Yeah, I'm really curious about always finding ways to improve and how we can be better and maximising performance for each of the individual swimmers. And bringing technology and data in, it was going to give us greater insight. Our performance analysts, when they're analysing a race, we look at things like start time, time to 15, time to change over, so how long it takes from the swimmer to touch the wall to the one to leave the blocks, how quickly they can do a turn, and even how they pace a race. So how quickly do they swim the front half of the race compared to the back half of the race. So all of that information goes into the data lake and into the databases that are queried by the relay app. It just gave us the ability to dive into so many more different options and give us so much greater insight and depth of thinking in what we were doing, really.
Thank you, Jess. Let's find out more about that system. Hi, Ali. Let's dive into the architecture. How does this whole thing work?
So the relay application has 3 main parts. One is the data extraction, transformation, and storage. The second is machine learning model training and deployment. And the third is the web application that coaches use to interact with the data.
Easy. So let's start from the beginning. How are you ingesting the data into the cloud?
So we have multiple sources that give us race results and athlete information. We use AWS Glue to load the data from the sources and write it into an S3 bucket called Lending.
Okay, so once you have this competition and athlete information in the cloud, what happens next? Why do you have 3 buckets there?
So the data that we receive from the sources is in XML and JSON format, which is not optimal for querying. So we convert this data and store it in an optimized structure in our data lake. And then we transform this data and store the curated views that can be consumed by the model training in the curated bucket.
Okay, so I can see that this swimming information is actually flowing through many components in the architecture. How does that actually happen?
We use AWS Glue to do the conversion and transformation, and we use a step function to orchestrate this data pipeline, which gives us like single place to monitor all data pipeline, and we handle our failure and retry logic in the step function as well.
Good, so the outcome of this initial part of the architecture is arriving at this curated bucket that has the data in the right structure to start the machine learning process, right?
Correct. So this data is being used in 2 places. One is the Aurora database, which is backing our web application. And also for training the machine learning model, we're using Athena, because our data scientists could have read the data directly from S3, but they preferred the SQL interface, which is what Athena gives us. And then we allowed the data scientists to use this data, train the model, and deploy the model in SageMaker.
It makes a lot of sense. So this model, the way I understand it, is trying to predict or to guess the best possible relay order. How is that kind of intelligence being consumed by the coach's application?
So this model is deployed in SageMaker. It gives us like the API endpoint. So now when the coaches use the user interface, they select the team and they request the relay order. This initiates a request from the interface to the API gateway, which in turn calls AWS Lambda, which then calls the model for that inference, and which returns the best relay order, and that data is returned back to the user interface.
This makes a lot of sense. Thank you for sharing this architecture with me. At best, the task of analyzing all the athletes' times is difficult and tedious for any human. But what about a machine? Hi, Jess.
Hey, how you going?
Look, I just learned how the system is built, but how does it actually look like when you use it?
Basically, when we're using it, it's showing us who the best swimmers are that we should choose and what order to swim them in. We're getting some web-based data on results and rankings, and then we're combining that with some race analysis data, which is more granular data. We can open up on an individual swimmer and look at more recent history, so looking at what kind of form they're in, look at how they swim a relay event to how they swim an individual event as well.
How much data are we talking about, and how often does it get refreshed?
When we're going into a competition, we'll have it on, I think it's about like a 15-minute refresh rate. But when we're outside a competition, we'll slow that down, and we really only need to refresh it probably once a week. But we speed that right up when we're having to make a lot more decisions in a lot shorter time frame in competition.
Does the application give you a breakdown of how the swimmers compare with each other?
Yep. What we can do is down here, we can manipulate this graph as well, where it puts those top 8 countries that we've selected. But if I want to look at, for example, if I use this one, I've got Australia in the red and America in the green. What this is showing me is, for us, we have a lot of depth in this event. So all of our swimmers here are below the Americans' time. So you've got Emma McKeon here with a 51.96 is faster than the Americans' best swimmer. So what that's telling me is we've got a 1 second advantage.
So it's your race to lose.
Yeah.
What do you do to help maximize your chances of winning?
Well, the computer does a lot of the work for me, to be honest. But I use some of my swimming intelligence and experience in swimming to, I can manipulate the 4 swimmers that it's selecting. And then I can look at some certain skill parameters here. So how they split a race, what they're like at relay skills. And this will give us some historical data on the last 5 individual swims that they've swum. So cool. I can dive into it a little bit to make my decisions a bit easier. And then once I'm happy with the 4 swimmers that are selected for each country, then I can run the first stage of the analytics. It will tell us who's going to win. So it's saying in Australia are going to finish first.
Yes, nice. Seeing how the predictions of this machine learning model are influencing relay lineups makes me wonder how exactly this part of the solution is built. Let's find out. Hi, Moose. Can you walk me through the machine learning process?
Sure. So we want to use machine learning to solve 3 different problems, basically. We want to predict the swim time for the individual swimmers. Using that information, we want to predict what's the final standing going to be of the team compared to other teams. And then using that information, we want to suggest the optimal lineup of the swimmers in the relay. So for that, we use a lot of data that's already been collected and curated for us and put into S3. So we basically split it into 2 separate parts. At the top, we have the development and experimentation phase. And then at the bottom here, we have the deployment phase. So we basically use this and then make an Athena SQL query from within the SageMaker notebook to get that data into SageMaker, where we can then build our models.
Great. So talk me about that iterative process of coming up with a good algorithm and actually measuring the quality, because we want to make sure that the suggestions that you give the coach, presumably, are actually accurate.
Yeah, so we actually start with the coach, right? They're the expert. They know what features they currently look at to determine the swim order. So we talk to them and figure out what features do they normally use. We then use statistical analysis to figure out what other features might be useful for the models as well. And then we iteratively try a couple of different algorithms like light GBM or XGBoost, which is the one that we settled on.
That makes sense. And once you've settled on that, I guess you earn that confidence by validating it?
Yes, we measure the accuracy by comparing the performance of the model to the results from previous competitions. So we'll check if the model accurately predicted the number of medals that the team earned, or we'll check if the model accurately predicted the swim time of the whole team.
Awesome. So once you're happy with the model, how did you expose that model to the coach's application?
Yeah, there's a whole pipeline to get the model from training into production. So basically what happens is, again, we go from Athena, that's where we start, and with the SQL query, we have a SageMaker training job that is actually training the algorithm using that data. This actually produces a final model, and then this model is uploaded into a SageMaker endpoint, and that's where the application can connect to.
That makes sense. Now, competitions are happening all the time, and athlete performance, I guess, goes up and down. So I'm guessing this model needs to be retrained very often. Is that the case?
It does. The coaches can actually choose to retrain the model when enough new data has been collected. And we actually use step functions to automate this entire pipeline that I just drew. So a step functions workflow will basically automate the entire process from Athena over here all the way down to deploying it into the SageMaker endpoint.
Okay, now if the coaches are the ones that make the call, then presumably there are no data scientists involved in checking the accuracy of the model. So how do you automate validating that model as well?
We do have a model verification step. It happens sort of between the model being produced and the actual endpoint. And that verification step, it just checks the results that the model is producing and makes sure that they're not completely out of bounds.
This really helps me understand how the machine learning process works. Thanks, Smooth.
The 2020 Summer Olympics, now the latest major sports cancellation caused by the global COVID-19 pandemic. So let's take a look by the numbers.
The pandemic had a huge impact on the world. I want to speak with one of their coaches to hear how this impacted them specifically. Hey, Simon. When the Olympics were postponed by a year, how did the application help you?
There wasn't a lot of meets going on at some stages throughout the world, so we didn't have a lot of data on some of the athletes. So I think where it really came in handy was all of their Olympic trials, their selection periods, because we were then able to capture that data, familiarise ourselves with the opposition team a bit more, and then get a feel, at least from a data point of view, of where their strengths and weaknesses lay to help us choose our best case scenarios.
So how did the application help you during the games?
We had a new event, the 4x1 mixed medley. You've got 2 males and 2 females. You swim them in any combination, and if you're trying to physically work out best combinations for each of the 8 countries that may be in the final, by the time you get through that, the Olympics can be over. So we were able to get best combinations on the other teams and then try and work out what team we had to swim in the heat in order to make the final without over-swimming our best swimmers all the time.
Simon, how are you using the app to benefit the athletes?
Okay, so we're able to better illustrate what the best teams are doing with their relay changeover techniques and how much time they're giving up with their combination of block times. And block time is the time that it takes from the swimmer coming in, touching the wall, to the swimmer's toes, taking over, leaving the block. With that knowledge, we can build that into our daily training environment, and we can give our athletes a target time. Now, one of the things that I've done with the women's 4x1 group was we aimed for 0.15, and that was like a pass mark. And they would practice that skill without distraction initially to the point where they were very familiar with it. I was then able to load through distraction of various forms, noise, ice cold water pistols in their ear, waving taser guns up and down for distraction, and see where that skill level failed. Because we can't replicate the pressure of the Olympics, but if we can teach the skill of what is required to be successful at the Olympics, well then we produce athletes that are given every possible chance to be successful.
That's great. Simon, thanks for sharing this with me.
My pleasure.
In sport, we're dealing with human beings, and the computer and the machine won't know certain things, like if a swimmer was injured or a swimmer had got sick overnight. So I might have to make a change there. The other bit is there's a huge coaching piece to it. We're really lucky in Australia that our coaches have a great relay intelligence, and they're quite strategic thinkers about their relay. So a coach might come to me and say, I'm thinking about doing this tactically, and I'll be able to put that scenario into the computer, and we'll be able to play that scenario out for the coach. So yeah, it's really there as a supportive decision-making tool. It all boils down to just wanting to support the swimmers and the coaches to be the best that they can be, and trying to help them find ways to do that. At the end of the day, we're racing in the pool for the gold medals, but we're also racing out of the pool to always stay one step ahead of the other countries and nations to make sure that our team are the best prepared that they can be when they stand on the blocks.
I'd like to thank the Australian Dolphins for spending some time with me and congratulate them on their outstanding 2020 Olympics. In Tokyo, they won 9 gold, 3 silver, 8 bronze medals, along with setting a new world record in the women's 4x100 meter freestyle relay. There is no doubt that their spirit of innovation is going to continue to propel them to even greater heights in the years to come.